In this example, we wanted to explain how queue can be maintained or realized using linked lists. In this example also, we would like to have a queue of characters. Thus, we have taken a structured variable known as lst such that it contains a character and a lst type of pointer variable. Also, we have defined another structure known as queue, which contains two data members, front and rear, which are lst type of pointer variables. The function initQ takes address of a queue type of variable and initializes rear and front data members of it to zeros. Whenever a queue type of object is declared, it has to be initialized by calling this function such that its rear and front will be initialized to zeros. The function isEmpty takes address of a queue type of variable and returns true if the queue is free or empty. Otherwise, it returns false. This is achieved by comparing the rear value with 0. If rear is equal to 0, the function returns 1, otherwise the function returns 0. Another function, node, which takes a character as argument, is written, which primarily creates a lst type of object and stores the character in it and assigns its next value as 0 and then returns the address of this lst type of object. The function insert takes the address of a queue type of variable or object and a character. So this character, whichever we send as an argument for this function insert, it has to be inserted into the queue. Thus, first in the function, we create a lst type of object such that it contains this p as a data member, and lst type of pointer variable x will point to that lst type of object. And then if the queue is identified to be initial free, that is empty, both rear and front of the queue type of object will be made or will be same as x. That is a new node. Otherwise, the new object, new ls type of object is added at the end and rear will be adjusted accordingly. The function remove takes address of a queue type of object, and if the queue is empty, will come out from the program. Otherwise, a ls type of pointer variable x is taken. It will made point to the topmost or front node, front object in the queue, and then front variable is adjusted such a way that it will point into the next node in the queue, that is with the help of the AR of front is equal to XOR next statement. Of course, whenever front will change it, we'll check up whether the front is 0 or not. If it is front value is 0, then we'll set rear also as 0. It is possible that when we go on remove object from the queue, at one point queue becomes empty. At that point we wanted again front and rear should be zeros. So for that we are adjusting or we are using this statement. Then after adjusting the front, the topmost node or the front node will be deallocated by calling the free function, and then before that the character in that node will be assigned to P and the same thing will be returned. The main program is written in which a queue type of variable A and queue type of pointer variable P is defined. A string X is taken such that in that one we have some characters which are supposed to be maintained in the queue. The pointer variable P is made pointer to queue type of object A, and then by calling init queue function, the queue A will be initialized such a way that its data members front and rear will be initialized to zeros. Then the for loop is used to traverse the characters of the string X element by element and push the characters into the queue. This is repeated till the end of the string is encountered. The last while loop is used to traverse the queue element by element and remove each time one character from the queue and print the same. The following slides will demonstrate how the queue is going to grow, at the same time how the links are going to get adjusted. Please make sure that you are cautious with the addresses, that is the link pointers, how they are going to get exchanged. This you have to observe. Initially both front and rear data members of the queue are zeros. When symbol A is inserted into the queue, a new node ls type of object is created. In that one A is stored. Its address is assigned to both front and rear. Thus their values are at the address of this new node. In this example we are taking it as 2000. That is the address of the new node having the symbol A. Next, symbol T is inserted into the queue. Thus, an ls type of object is created by calling the node function. In that one, T is stored, and now this has to be added at the end of the queue. Thus, rear will be adjusted. However, before moving the rear, the new node address is maintained in the current node, and then rear is adjusted. The new node address we consider 2008. Thus, the 2008 is stored in the previous node's next variable, and then rear will be made as a pointer to the new node. This time symbol E is inserted into the queue. Thus, a new node, ls type of new node is created, and this has to be added to the queue at the end. Accordingly, rear has to be changed. Address of the new node is assigned to rear. At the same time, the new node address is written into the previous node's next variable. Now we come out from the for loop. Then the last while loop of the main is going to get executed. That is, this time one character, one node will be removed from the queue, and then whatever character is available in that node, it will be printed. Whenever we remove, this time front is going to get adjusted. The following slides will explain how the same thing is going to take place. Now symbol A is going to get printed. The node having symbol A will be removed. Front is now made point to the next node in the list. Now when we remove, that is when the function remove is again called. Now symbol T is going to get printed, and the node having symbol T will be deallocated, and then again front will be made pointed to the next node in the queue. This time symbol E is printed, then again front will be made point to the next node. However, for this node there is no next node. Next value is 0. Thus front value becomes 0. Whenever front value becomes 0, rear also becomes 0. Like that, the queue becomes empty now. In this example, we have explained how queue can be realized with the help of linked lists.